Here we have the set Q of rational numbers, and in this we define a correspondence this way. X is related to Y if X and Y are related by this relation where H is some integer. Okay, we have to prove that R is an equivalence relation, and then we have to see if 2/3 and 4/5 are in the same equivalence class. Okay, so first of all we're going to rewrite this equation a little bit, okay, just to make it more clear. So we're multiplying this by 3 and subtract this. So if we do that, we have 3x is equal to 3y plus h, okay, and that is equal to 3 times x minus y equal to h, right? And h is supposed to be some integer. Okay, so this is a better way of checking if two numbers are related. It's just subtract one from the other and then multiply by 3 and check that the result is an integer. If that happens, then x and y, well, x is related to y. Okay, let's prove that this is an equivalence relation. For this, we first need to check that it is reflexive. Okay, reflexive means that x is related to x. Well, it's easy to check that because if we substitute here y by x, what we have is 3 times x minus x. That is 0, and 0 is of course an integer, so it's okay, right? Then it's also symmetric because if x is related to y, that means that 3x minus y is equal to h, which is an integer. But then that also means that if we multiply this by -1, we have 3 times y minus x, that's equal to -h. But -h is also an integer. So it turns out that the difference y minus x multiplied by 3 is also another integer, which means that y is related to x. So it's symmetric, right? And finally, transitive. Transitive means that if x is related to y and y is related to z, then what we have is the following. For the first, we have that 3x minus y is some integer h, okay? It's an integer, right? From the second, we have the 3y minus z is some other integer, let's call it h prime, okay? So if we add these two equations, what we have is, well, 3x, and then y cancels here and here, okay? And then we have z, so we have 3x minus z in the first, the left-hand side, right? And in the right-hand side, we have the addition of these two numbers. But of course, if you add two integers, you also have an integer. So it turns out that the difference x minus z multiplied by 3 is also another integer, which means that x is related to z. So it is transitive, all right? So the first question is already answered. It is an equivalence relation. And for the second, what we have is just we need to check whether these two numbers satisfy this relation. So we just multiply 3 by 2/3 minus 4/5, okay? And well, this is equal to, I multiply, this is 3, I multiply this by that, this is 10 minus 12 divided by 15, right? 10 minus 12 is minus 2, times 3 is minus 6, so you have minus 6 divided by 15, or if you prefer, minus 2 divided by 5, okay? That's 2 divided by 5. But clearly this is not an integer. So 2/3 is not related to 4/5, which means that they belong to different equivalence classes.